Here's my 486. It's running a Hello World demonstration at 4 megahertz. It doesn't work at 1 megahertz. I don't exactly know why. It can run programs from just the ROM at 1 megahertz, but if it has to use the RAM, it doesn't work. So I have to speed it up to at least 4 megahertz in order to get it to work. The minimum speed that these chips are supposed to be able to run at is 8 megahertz. If I run it at 1 megahertz or slower, weird stuff starts to happen. For example, in this screenshot, the ADS line goes low for less than one entire clock. This means that the ready signal counter doesn't get reset, which means that it doesn't hold the ready signal for the right amount of wait states because it never had a chance to reset. This often makes the system less stable at lower speeds than it is at higher speeds. I don't know that it's possible to use Verilog code to fix that issue, because if stuff is happening more often than on the rising edge or the falling edge of a reference clock, then it's like certain registers that are within always blocks can't be modified by other ones. This creates a situation where certain things work on the test bench but not on real hardware. This isn't even the biggest issue I run into when I'm trying to run this thing too slow. If I'm trying to run it slower than 1 megahertz on a 555 timer, for example, the ADS line will just kind of randomly pulse in the middle of a clock cycle. When this happens, it messes up the FPGA registers because it's pulsing and latching data when it's not supposed to be. And the solution is to just run the system at least 1 megahertz. So if I put a 16 megahertz crystal oscillator into the system, it'll actually run at 16 megahertz, and it is surprisingly stable too.